Okay.
Yeah, go ahead and start. I'll just play around with this.
Good morning, everyone. Thank you so much for joining us today. The topic of this workshop is leading with safer materials and avoiding regrettable substitution. I don't know how familiar folks are with the term regrettable substitution. I know I wasn't, so I looked it up, although I thought I did, and I have actually a couple of examples of regrettable substitution. Regrettable substitution is when a company substitutes a chemical for another chemical and does not consider the human health impacts such that workers and the public are harmed. And then, only then, do they say, oh, do they have the regret, right? And say, oh, looks like we have to do this all over again. A couple of good recent examples that you may all be familiar with, at least, peripherally, is a few years back there were a lot of recalls for children's toys and jewelry because of very high lead content, up to 95% lead. And that caused the federal government to act and pass the Consumer Product Safety Improvement Act, which banned lead in toys and products for children. But since then, many toy and jewelry manufacturers merely switched to cadmium instead, which is an equally, if not more, neurotoxic, et cetera, harmful metal. And it's because they just said, okay, well, what is legal for us to use? Not what's safe, not what's healthy, but what's legal, what's not banned. And so they just immediately took the nearest, reasonable, still heavy, still malleable, having the right properties as a chemical, but not healthy or safe. So of course then, as several states took action against cadmium, now those same companies are forced to retool again and seek another material for their products. And of course we hope very much that they don't just keep going down the periodic chart to the next metal that may be harmful as well, and that they actually do a more thoughtful evaluation, which is what these folks are going to talk about today. Another example, many states banned, and the federal government reached an agreement with the makers to phase out toxic flame retardants known as PBDEs, polybrominated diphenyl ethers, and from products and from actual manufacture in the entire country. And a lot of product makers did the same exact thing as the lead and cadmium snafu and said, okay, what is available, what isn't against the law for us to use? And many companies switched to equally hazardous halogenated chemicals called tris, chlorinated tris. So there's TDCPP and TCEP. And so, here we are, back again with a very regrettable substitution, but chemical that isn't banned anywhere until New York State took action last session to ban one of the two chlorinated trisses from products made for children age 3 and under. So, that's what we're talking about when we're talking about regrettable substitution, just a situation in which one toxic chemical there's a drop-in substitute for it that has a similar hazard profile, has similar chemical makeup, and next thing you know, you're back in the same boat. So today, to sort of be more solution-oriented and talk about how to avoid regrettable substitution is Barry Chick from Naturepedic, Kate Winnebeck from the New York State Pollution Prevention Institute, and Mark Rossi from Clean Production Action. So Barry, could you start us off? You can wander around if you want.
I can wander around.
I think you have to turn that mic on though, but the camera can follow you.
I have to speak into the microphone.
Or else it will not be captured. Thank you. You have to turn it on.
That's hard.
Turn it on?
Yes.
Okay, I'm talking to the microphone, but I'm not. I'm talking to you. All right?
Okay.
I'm Barry Chick, board-certified environmental engineer, also certified by the Institute of Professional Environmental Practice. I'm also a certified hazardous materials manager, master level. I'm also a diplomat forensic engineer. I testify in court. I'm an author of 2 textbooks on environmental matters. I'm a registered professional engineer, certified by the Ohio EPA, and a few other things. Okay? That's my background. Now, as far as what we're talking about today, I would prefer that this not be a one-way conversation. I would prefer that instead of me just talking at you, you ask me questions, tell me what's important to you, and let's talk about it. And I'm prepared to take any questions about anything, and let's start a conversation. Anybody willing to start? Somebody. Throw something at me. What's naturepedic? Okay. 8 years ago, I walked into a baby store for the first time in my life. Until that day, I had never, ever, ever been in a baby store. My wife used to buy all those things. That's the honest truth. Okay? My wife sent me to the store to buy a crib mattress and a few other things for our first grandchild. 8 years ago. I walked into the store, and I ask questions, and I read the law labels, you know, do not remove under penalty of law. I realized that every single mattress in the store was polyurethane foam with a vinyl cover. I said, well, went to the salesperson, I said, what else you got? And she says, what's your problem? I said, well, I know a little bit about polyurethane foam, a little bit about vinyl, and not for my grandchild. She said, come on. She told me something that I will never forget. If it wasn't safe, government wouldn't allow it on the shelf. Come on. Okay, I have never forgotten that. That moment was a turning point in my life. One of several, but a very important turning point in my life. If the government, if it wasn't safe, the government wouldn't allow it. This is the way crib mattresses are made. They know what they're doing. There's a reason for this. This is obviously the right way to do it. Okay? That's the mind of an average person. Okay? And I looked at her and I said, sorry, I know better. But she wouldn't believe me. And that has become the biggest obstacle that Naturepedic has faced since that moment. And that is talking to average people and saying, there's a problem. And the average person not saying back, you're an extremist. You don't know what you're talking about. I went to doctors, to pediatricians, and I said, do you know what babies are sleeping on for 15 hours every day? I mean, this is your business, right? I'm not a medical doctor. I don't remember the exact statistics on that one, but I would have to say that a majority had no clue, you know. And the ones that did have a clue didn't seem to care. And one, when I told him I was starting a company and all this, he accused me of taking advantage of nonsense. I mean, it just, I was really blown away by all of this. Anyways, that's the story of Naturepedic, all right? So, and at the beginning, most people would not buy our mattress. Only a very few people who were ahead of the curve, who understood the issues, they found us, we found them, and you know, we started making sales. But things are changing. I'm telling you, everybody, things are changing. The day will come when, and it won't be that far in the future, where most people will understand we have serious problems with chemicals and serious problems with the fact that manufacturers have no clue what they're doing. They really don't. Somebody comes up with a cheaper material, manufacturer says, oh, I can make my product for a little bit cheaper. That's it. It doesn't, the questioning does not go beyond that thinking. And that's the way it is. But it's changing. People are beginning to wake up. And that's, you know, I'm part of that story, a little tiny part of the story, but I am part of it. Okay. Yes, sir.
Well, I'm curious whether you took air samples of the child's environment and other situations that you would then use in formulating your products. I've been, sure. I've been performing indoor air quality studies for many years, and I know that you can't take samples in an atmosphere in a room of any kind without, coming up with parts per billion, parts per trillion levels. Sometimes parts per million. That's a lot if you get that much of various chemicals from the environment, the built environment that you're talking about. So did you sample the child environment and see what you were dealing with and go from there and then repeat it with your products? I'm curious.
I did not sample the environment. I only sampled products. So basically what I did was I reached out to somebody by the name of Dr. Marilyn Black, who started it's called the Green Guard Environmental Institute. And what she does is she will sample individual products. If you really want to know the truth, actually it started by her reaching out to me. She was looking for something for her grandchild. And she got a hold of me is how it actually started. And she has the equipment, I don't. And she tested polyurethane foam and couldn't deal with it for her own grandchild. Found us, tested one of our mattresses and bought it on the spot. That's what happened. And then she told me what kind of results she was getting on some of the other materials she was testing. So I didn't test the environment, but I did test various materials. And we have a program to this day with Green Guard where they test our products. They have a program where they test anybody's products, and they have now 3 different levels that you can meet. And if you meet any one of the 3 levels, you can get certified to that level for your product. We take it a step further. Most people who will test a product with Green Guard will test the entire product. You give the whole product as is to Green Guard, they stick it in a chamber and tell you what the off-gassing is. What we do is, in addition to that, we will test every single component individually so we can find which components have whatever issues they may have, so we can focus on component by component by component to further improve the product. So that's what we're doing. Your hand was up there? No?
What's your product made of? What's your product made of?
All right. So here's what we did with our product. We've done this twice already, so let's take it sequentially. The first thing that we did was we said, okay, we don't want polyurethane foam, we want the vinyl. What are we going to do? Let's go back to an era before polyurethane foam and vinyl came onto the scene, okay? All right. Let's go back to an era before polyurethane foam and vinyl came on the scene. And that era is cotton, steel inner springs, just to give it some shape, because you can't put a baby on a clump of cotton. It would be an oversized pillow and dangerous, okay? And organic cotton fabric. So all our cotton, and then we went to organic, of course. So all our filling is organic cotton, and the fabric is organic cotton. Okay, we have to put some flame barrier in there, which is silica-based, which is the safest I could find, and steel inner spring. Currently, we have another version of that where we use a food-grade polyethylene foam instead of the steel inner spring for those parents who need a lightweight mattress, because the steel is a bit heavy. Okay, so we found a polyethylene-based foam that's much safer. It doesn't have all the toxic chemicals that go into polyurethane foam. It also doesn't burn as heavily as polyurethane foam, so we actually have a new model coming out that looks like we'll have 0 fire retardants, 0 flame barrier, period, because we were able to design it in such a way that it will meet the federal flammability. We're the first mattress that meets the flammability standard. So basically, all our mattresses are certified organic under the Global Organic Textile Standard. And they're also certified to the highest level of Green Guard, also recommended by Healthy Child, Healthy World, and a bunch of other organizations. Okay? And that's it. Okay, thank you very much.
You ready, Kate?
Sure.
Did you want to? I will do the Q&A. Yeah, I can bring the microphone to people who can
Okay.
say what.
So I don't need this right now.
Okay.
All right. So while Katie's getting this set up, I am Kate Winnebeck. I'm from the New York State Pollution Prevention Institute. I'm going to start off today. Let's see if I can do this off the top of my head while we're getting this set up. I'll give you, there we go, a quick kind of intro to who is the P2I, the Pollution Prevention Institute. How many people have heard of us? Good, most people. That's good. Hopefully you'll learn something new and great about the things that we do today. Thank you.
Oh, no, it doesn't.
No?
You pushed me back over here.
So, the Pollution Prevention Institute is a statewide organization, so we support communities, businesses, all throughout the state. You know, we're based in Rochester, we're at RIT, Rochester Institute of Technology, but we really are statewide. We have projects going on all over the state. Our goal really is to reduce the use of toxic chemicals in New York, you know, have efficient use of raw materials, really to kind of clean up and prevent pollution, right, with the Pollution Prevention Institute. So that's really our main goal. Thank you. Statewide coverage, like I said, we have kind of 5 arms, I'll call it, to the P2I, kind of 5 different program areas. We have some R&D, research and development, which is really done with the partner universities. So we're a partnership with RIT, RPI, Rensselaer Polytechnic, Clarkson, and UB, University of Buffalo. So they kind of their faculty, students get involved and do some research for us. We have a direct assistance program, so that's working, you know, with a company on a very specific problem. It could be a specific problem they have and they know the solution and need help getting to the solution, or it could be we have this problem, we have no idea what to do. We need you to help us just figure out what the solution is. Community grants program, so that's funding for community organizations to do kind of education, outreach around, you know, environmental issues. Some professional training and outreach, we do a lot of workshops on a lot of different topics. And then we have sector projects, so we do some very targeted work in specific sectors. So one thing we did a year or 2 ago now is we had a big hospitality program, so we worked with Audubon and their Greenleaf program and helped some properties in New York State actually go through that program, so that was pretty cool. And right now we have a sector project with dry cleaning, so I'm heading that up, and I'm going to kind of talk about dry cleaning and dry cleaners and why that's an issue and what they've, as an industry, kind of had problems with substitution as well. So, like I said, I'm going to talk about 2 case studies today. They're very different, and they both relate to substitution. The first one, alternative dry cleaning technologies and why, you know, that's kind of an issue. And another one is more a specific company that uses life cycle assessment really to help them with product design, how that tool can be used, you know, for product design. So dry cleaning. Most people don't realize that dry cleaning actually uses a chemical, right? You actually wash your clothes in a chemical solvent. It's called dry cleaning because it doesn't use water. You know, it's kind of funny, I've done a lot of on-the-fly surveys, and most people think dry cleaning is done either with a gas or with a solid. Yeah, kind of interesting. It's kind of similar to, like, if you imagine a combination washer-dryer, right? You've seen those now. That's the new thing, is you put your clothes in and they come out clean and dry. So it's kind of the same concept with a dry cleaning machine. You put your clothes in, they get soaked in the solvent, they get spun to get the solvent to come out, right? And then the clothes are clean, okay? The solvent gets reused, goes through a whole bunch of filters, you know, gets condensed and gets reused. Some of the big problems with dry cleaning, you know, there's the health effects from the perc, right? So perchloroethylene, which is traditional dry cleaning fluid, is not very nice, both to our health and to the environment. The dry cleaning machines, as much as the manufacturers want to tell you, oh yeah, they're perfectly sealed, there's no leaks, there's no issues, we know that there are, right? And simply the fact that somebody has to open that drum when the clothes are clean, right? You don't get every single bit of that chemical out of your clothes, okay, when they come out. So there's some residual material left in the clothes, that's an issue, you know, and then there's some release to the environment, also an issue. So dry cleaners are looking at alternatives, obviously. You know, you read about contaminated sites all the time, sites that are contaminated with PERC. So what do I do if I'm a dry cleaner? I don't want PERC anymore, right? Especially, you have to have a permit, you have to go through training, you have to pay for hazardous waste disposal. I don't want to pay for that. It's costing me a lot of money. So what do I switch to? So we did a survey about 1.5 years ago sent out to all dry cleaners in the state. So there's a little over 2,000. And about 1,200 of them are in the greater New York City area, okay, which probably isn't that surprising to everybody. If you ever walk through Manhattan, you kind of see one pretty frequently when you're just walking around. And we found that cleaners upstate, very few of them actually use PERC anymore. Last year, I was actually specifically looking for a cleaner to wash some clothes in PERC because I was doing a comparison, and I had to call about 15 cleaners in Rochester to find one that did. So very few upstate use PERC anymore, but what have they switched to? They've switched to hydrocarbons. Okay, that's kind of been billed to the industry as this latest, greatest technology is hydrocarbon. It doesn't have the same issues as PERC, but now it's flammable. We don't see the same adoption rates in New York City because in New York City, a lot of the cleaners are on the first floor of an apartment building, right? Whereas here upstate, they might be standalone buildings or they're in kind of a shopping mall, shopping center, right? You don't have the same issues with people living above you. When you have the people living above you, and now you have this flammable material, you have to install sprinkler systems. Sprinkler systems are expensive. So in New York City, they're not adopting these hydrocarbons. They're just doing nothing. They're still in PERC. Most cleaners in New York are still in PERC. A few have converted to Green Earth. If anybody's heard of that, that's kind of the trade name. It's silicone, siloxane D5. There are a few kind of controversial health effects around that. You know, Canada is regulating the use of that same silicone material in personal care products. Same thing that might be in your conditioner to make your hair nice and silky. So they're regulating that due to potential aquatic toxicity, right? So now there's questions about, is this really safe here in this country, et cetera. So one solution, and kind of the best solution, is wet cleaning. So wet cleaning actually washes dry clean only clothes in water, okay? It sounds scary, I know, but it works. You know, and that's kind of the initial reaction both from cleaners and from consumers is like, whoa, I do not want to put my cashmere sweater in water, right? Because that's going to ruin it. That's what I've been taught. That's what I know. This isn't going to work for me. So that's one hurdle to get over with both cleaners and consumers, to understand there is new technology. You know, it might not be the same as what you're thinking it's going to be, but it can still work. So real quick, kind of the way professional wet cleaning works is now you have a separate washer and dryer. It washes your clothes. It's super, super sensitive. You know, so like your washer at home, even on delicate, it probably spins at a pretty regular rate. This might spin, you know, once every 3 minutes. You know, so it's a lot more sensitive. The temperature controls are a lot more, just the equipment itself is a lot more sophisticated. You know, somebody asked me, well, can I put this in my home? Sure, you have $50,000, you can put that in your basement, you know, but you're not going to do that. A professional cleaner, okay, that could be an attractive option for them. So when we look at alternatives, so these are kind of the common alternatives that are out there, what their equipment costs are, what their average cost for first 5 years of cleaning, right? So we have maintenance costs, detergent costs, et cetera, and how do those really come out? So when you look at them and compare them to PERC, wet cleaning is also the cheapest option, right? Which is pretty interesting too. So now you have, the problem that we're finding is all these cleaners now that have gone to hydrocarbon, they invested a lot of money to get rid of their PERC machine, right? You have to pay a lot of money to get rid of it. Paid a lot of money to get this hydrocarbon machine. Now they're just waiting kind of for the hydrocarbons to be regulated and for people to really kind of step up and say, okay, this isn't very good, this isn't bad, you know, we want you now in wet cleaning. So one of my responsibilities is to not just educate, you know, PERC cleaners, but let's educate all the cleaners that are out there. Here are the different options. Here's why one might be better than the other. And there's all these additional benefits too, right? So it's not just cost, it's wet cleaning actually cleans better. The equipment is more sophisticated, so it means there's less chance of shrinking, less chance of color fading. All those reasons why you might be mad at your dry cleaner, there's less of those actually happening. And then wet cleaners can actually market themselves as environmentally friendly, right? Which is a huge marketing ploy for them. It's a huge advantage in today's economy. So that's kind of dry cleaning and kind of the industry as a whole, right? So this is an instance where there's really a lot of education that we need around, both for consumers, because if consumers are asking for it, a dry cleaner is going to do it. I've had a couple in my travels in the last year or so that have actually said that. I live in a community where people care about this a lot, and they're asking me for it. If I don't do something to change, I'm going to lose these customers. And I'm going to lose these customers that bring me clothes every week, right? So that's their bread and butter. Those are the people they want. They don't want me that come in once a year with some fancy dress, right? Big deal. They want somebody that's there every week, that's kind of a consistent customer. And then we have life cycle assessment. And I believe if you guys are around tomorrow, Anahita Williamson is going to talk about life cycle assessment 2 in the business tools section. So I'm just going to go over kind of briefly, what LCA is and how this company used it. So really, life cycle assessment aims to kind of quantify environmental impact throughout the entire life cycle of a product or of a material, right? So from when we first get the materials to make this product all the way through till the end of life, and what happens with it. So this company that we worked with, we compared 3 blood pressure cuff designs. So if you've ever been in the hospital and had to have your blood pressure taken, it was probably a disposable cuff versus the reusable ones that like your doctor's office has. So that's what we looked at. We looked at disposables. And really the goal for this initially was, okay, we want to know between these 3 models that we have, which one's the best, right? However you want to define the best, and that's kind of a whole different discussion. And then it became more and more as we were talking with them, and this was their design team that we were talking to, it was, okay, what do we do for the next cuff, right? Because now we have these 3 cuffs, that's great, but what's next? And how do we take these results and kind of build from it, okay? So what we had when we were done is a comparison of 3 models with different materials, and we could point them at, this material is contributing significant environmental impact, either in the end of life. Can you affect the end of life of this product somehow? Is it the actual material itself and how you're making it, et cetera. So that was really good for them to see how you could actually pinpoint, here's the exact either phase of the life cycle that contributes, here's the exact material, here's the energy use, et cetera, in that to help with it. Okay? So you want to do questions now or later?
I would prefer to wait.
Okay, that's fine.
Good morning. Yeah. Good morning. I'm Mark Rossi. I'm the co-director of Clean Production Action and the co-chair of BizNGO, and I'll tell you more about those in a moment. But I just want to see, so who do we have in the audience? How many of you are from a business? A handful. How about government? All right. We are here in Albany. How about academia? Oh, another mix. And anybody from an NGO? A couple. Oh, good mix in the audience.
You're all set, just up and down.
Wait. That's right. So we've got a beautiful picture of a waterfall here on this screen. Okay, so Clean Production Action is an environmental organization, and we're really focused on identifying safer alternatives to toxic chemicals, to chemicals of concern. And so we do that through a number of ways. One is we develop tools, and I'll talk a bit more about that. Thanks to David Levine this morning for mentioning the green screen. I'll touch on that, which is one of the tools that Clean Production Actions developed. We engage with companies around sustainable materials and thinking about how do you move to more sustainable materials. And we create networks for moving this work forward, and I'm going to talk more about that, which is the Business NGO Working Group. So BizNGO, the long title is Business NGO Working Group for Safer Chemicals and Sustainable Materials, and well, that's why we shortened it to BizNGO. But the title really reflects what we're about, right? It's about bringing together multi-stakeholder organizations to jointly work together to find solutions to chemicals and materials. And one thing that's really not in all of our materials, but really we were focused on finding the highest common ground that we can find. It's not about really finding a low bar level of compromise. It's really setting a high bar set of criteria and vision of where we want to go. I didn't include a slide of this, but one example of this is BizNGO developed a set of principles for safer chemicals. So we have 4 principles, and they're visionary principles. And principle 1 is to know and disclose chemical ingredients in products. Principle 2, which is really what this session is about, is assess and avoid hazards, right? How do you identify problematic chemicals and move to safer alternatives? Principle 3 is commit to continuous improvement. And principle 4 is support public policies and industry standards that move the above 3 principles. But what that reflects is it's a real visionary set of principles. I mean, none of the companies that we're working with and very few companies are at this point of being able to do all these activities and really do them well. And so we recognize that, and we set a set of principles that are visionary, and we want to then develop metrics to how do you get there. So, oh yes, I have to flip through this. So who's in BizNGO? So it's a mixture of organizations from the healthcare sector. We have these monstrous group purchasing organizations like Premier Innovation, to Kaiser Permanente and Catholic Healthcare West, the retail and cleaning products sector. So we have Whole Foods, Staples, mission-driven companies like Method and Seventh Generation who make cleaning products. The building sector and companies in that sector are well represented, from architectural firms like Perkins & Will to manufacturing companies like Shaw Construction Specialties. And the electronics sector is also very active with Hewlett-Packard and Dell, among others. And then a whole bunch of environmental organizations are working with us. And so we have a number of projects. 5 minutes. Okay. Yeah, I have to move along. So we have a number of projects and up there, and the one that I'm going to really focus in on is Chemical Alternatives Assessment Protocol. So what's this analogy here?
Out of the frying pan into the fire.
Exactly. So how do we avoid this, right? This is the point, right? How do you avoid the regrettable substitution? And I was thinking another appropriate slide for this one would be, it's not easy being green. Which is, and this is not meant, I just wanted to put this up as an example, but this is something BizNGO just released last week at our annual meeting, which is that's a flowchart decision logic that leading companies are using to identify safer alternatives. So you can't see that. But so this should be a little bit, a little bit better.
All of the presentations will be available on the website afterwards.
I was going to really walk us through these first 3 points in this, these ones in yellow, steps 2, 3, and 4, about how do you start to really move to a safer alternative. Because it's a real challenge. So if you're at the top, you identify your chemical of concern, all right, you've got deca-BDE, brominated flame retardant, you want to get out of it. How do you know that you're getting into a safer alternative? How do you know that you're not avoiding a regrettable substitution? Right, so this is a real challenge. So the core part of this, right, is what's the functional use of a chemical? So in this case, it's a flame retardant. And you've got an application, let's say it's an electronic product. And now it's like, okay, well, how can I replace that alternative? So functional use, I'm going to cruise along here. But so that you've got, and when you're looking at alternatives, you're going to potentially have a range of alternatives. One, you could go from deca-BDE to another chemical, like Kathy mentioned, another brominated flame retardant. You might be able to go to another material that gets rid of the functional use. And this is a much higher level, right? If you can get out of that functionality of not needing that flame retardant because you've gone to another design, another material, that's a much preferred option because now the toxicity of that functional use is out of the product. So it's really important, how you frame this question. This is then just, taking these chemicals, materials, products. You look at flame retardants, right? You can go to another flame retardant. You can use an inherently flame-resistant fiber. You can redesign the product. So like the chairs that you're sitting on have foam. Barry's mattresses. The chairs that you're sitting on have foam. You could redesign that chair so that you actually don't need the foam, which is going to need to be fire retardant, or you could get rid of the material, the flame retardant in the first place. So assess hazards. Is there a safer chemical? So I was just going to do a quick dive, apparently, into the safer chemicals, because this is a real challenge, and the typical approach on this is to go and look at, well, okay, DECA-BDE, I've got my list of alternatives. Is it on a list, right? Is it on a list of concern? And this was taken from a friend of mine, Tom Lent's slides, and he was looking at this in the case of the building sector. So here you have in the building sector, you start off with lead, and you've got a set of chemicals that were initially set up by the U.S. Green Building Council. Then there was this Green Guide for Healthcare that came out with a whole another set of chemicals of concern. And then you had new lead for healthcare, which had a different set of chemicals, a lead pilot. Now you have the Living Building Challenge, which has a somewhat different set of chemicals. These are the EPA Priority Chemical Action Plans. This is the Perkins and Will list. And let's see, what else did we, and they added some new chemicals. Then the Living Building Challenge. Watch this. So this is all, right, if you're in the building sector, you can play this out over the past few years. Healthy Building Network and Clean Production Action created a red list of lists, which is like 3,000 chemicals, right? So this is this issue. If you're taking a list-based approach, okay, great. If you're taking a list-based approach, you're going to be going through, you're going to be constantly churning as you identify more information, right? So how do you, and this is one strategy, and this is a first step. Absolutely take a look at the alternatives, see if they're on a list. Let's see, get this. There we go. But you could take a more systematic approach, and what we've developed at Clean Production Action is something called the green screen, which takes a look at, so now what this does is it takes a look at a chemical, takes a look at 18 hazard endpoints, and then you would collect the data on those 18 hazard endpoints, you'd plug it into the system, you'd rate those by high, moderate, low. So let's say you've got your alternative brominated flame retardant. Is it a carcinogen of high, moderate, or low concern, et cetera? Reproductive toxicity, neurotoxicity. And then you would be able to put that chemical at a different, rate that as a benchmark 1, 2, 3, or 4. Now, this is a great system. The challenge is gathering data on 18 endpoints for an individual chemical. That is a time-consuming process. This is an example of what US EPA did this, so you get an example of this. You've got a list of flame retardants down the left side, you've got the endpoints on the right side, and then they rate it high, moderate, or low. Once you have all that data, which is a challenge to get to, but once you have it, then you plug it in and you would get a green screen assessment. I mean, the nice part about the green screen is once you have the data, like you look down there on this lower chart on the left-hand side, you don't need to know all that data. You just look there and you go, oh, it's a red, it's an orange, it's a yellow or green. By that color coding of the chemical, you immediately know where it stands in the system, even though it's backed up by a huge amount of data. So even though it's complex to get to the information, the solution is really clear. So just a couple of tools on this. We're working on a quick screen assessment process. We're working with Tom Carter and the Works on that. We've also been working with the Pharos database, which Healthy Building Network has developed. And I was going to say quickly what they've done. They've got over 9,000 chemicals in a database. Oh, just both of these systems are proprietary systems, the Works and Pharos. You have to pay to get into those systems. But Pharos has done a system based on a green screen type approach where they're providing all kinds of data on 9,000 chemicals in their system. that's a chemical-based approach, right? And it's very complicated. Much better is to redesign so you don't need that functional use in the first place. You know, go to a different material, go to a different chemical, go to a different product, design out the need for that functional use in the first place. You know, just lastly, and this sort of ties into Kate's presentation, I mean, the way we've set up this protocol is once you've screened out, what you do is you go through, you do your hazard assessment, you screen out the nasty chemicals so that you've got a set of better chemicals. It's a challenge to get to green. And then you can kick in the alternatives into some type of life cycle assessment if you want to do a further assessment of that information. Or you can say, okay, I've got a sufficient enough information, and then I'm going to select my alternative. And so this process, this protocol that we've created, is set up to be, this is how companies are making decisions. There's a number of other tools, methods, alternative assessment methods that are out there. I developed a framework with the Lowell Center for Sustainable Production. The Interstate Chemicals Clearinghouse has a whole Safer Alternatives wiki that's up online. There's another tool in the U.S. Environmental Protection Agency's Design for Environment program has developed somewhat similar metric for evaluating alternatives. So to close, and Kathy said that you're going to post this, but here's a whole bunch of set of resources where you can go and get this information and more. The bizngO.org, Clean Production Action site on the green screen. You've got the work site, Pharos, and UC Berkeley, that should be University of California, Berkeley, has an online, publicly available database that they've set up called Plum, which has all these lists of lists in that, and that's publicly available. So that's a quick run through doing alternatives assessment. I mean, this is something we could spend a day on. So, but thanks for the opportunity to be here, and look forward to answering questions.
We'd love to spend a day on this. Anyone have any questions for the panel?
Mark, I was wondering if you could talk a little bit about the green screen in practice, and are there companies that you work with, and if so, how does that work?
Yes, so the green screen is being used. It's being adopted pretty quickly in the electronics sector. So Hewlett-Packard uses the green screen, so they're looking at alternatives to the flame retardants. They're using the green screen for that, as well as looking at it for plasticizers. So in the electronics sector, we've seen a lot of adoption of the green screen. We're also working with companies that will do green screen assessments for you, toxicologists, and there's a company, NSF International, and Tox Services, who are doing green screen assessments for companies now. And lastly, the Green Chemistry and Commerce Council, which is this collaboration of businesses organized by UMass Lowell. They've been doing an assessment using the green screen of plasticizers. So that's, some of the uptake rate right now around the green screen.
I think I'm going to reframe this just a little bit as a discussion as opposed to a straight-up Q&A. So that way, if anyone has a response to anything that anyone else says, then we can just make this a little more free-flowing. I think it's a small enough group for us to be able to do that, and then more people will have the opportunity to speak. So, does anybody have any questions or comments in that new frame? Oh, come on, don't be shy. There you go.
Hi, I'm Anita Wilson from the Clean Production Institute. Just a quick comment. I went through the green screen training some time ago. It was very interesting, and we perform life cycle assessment at the P2I. Obviously, we see a lot of value in these types of tools. There's a lot of challenges as well. For one, they take a long time. LCA itself can be very costly. So how do we get this information to, like the large companies may be able to afford to do these types of things. How do we get to the small and medium-sized companies that are looking for alternative chemicals? For instance, we're trying to publish more from LCA. The green screen, is the intent to then publish more papers so this information can get out there? How do we do that outreach to these small, medium-sized companies?
It's a great question. The whole scalability of this issue, which is, it's the real challenge. And, just sort of some context too, right? LCA starts really hot in the late 80s and early 90s. So you've got a really good, 20 years running head start on, sort of moving LCAs for life cycle assessments. I mean, the chemical hazard assessments and this approach is really just starting to take off in the last 5 years. So, I mean, it's much more in its infancy, but that's like why Clean Production Action's teaming up with the Works, so how do you create systems for scalability of this information? And we're operating on two challenges. One is the cost of getting this information, and then how do you get that information out there? Now, ideally, you'd have the electronics sector, for example, create a consortium that would say, okay, because they all have to answer the same question. Flame retardants, plasticizers, what am I doing about these? Plastics and products, the chemistry of those plastics, what am I doing about them? So I think, one of the areas where it would make sense, and we haven't quite seen this set up yet, but you would have a sector create a consortia to go and create that information and to share that information. And at the same time, then we have to work on strategies of getting the information we collect out. And there's a number of examples of that. I think the Interstate Chemicals Clearinghouse, Beth Muir is here from New York State. Hi, Beth. And Pam Eliason, who's up there, she's coordinating the Safer Alternatives work. I think that's a very good example of getting more information out into the public domain. The UC Berkeley's Plum database is another example. So what we're going to see is, and we're seeing this now, you've got these tiers of information that are going out. When you pay for the information, you're going to get more and better and in-depth information. And then we're going to work to get more of that information out into the public domain. So that's the goal. It's definitely going to take a little while to get there and get more information out into the public domain, but we need to.
I have a question. I'm going to jump here. How do we get, and this is for everyone, I know that most governments, of course, don't use hazard assessment and they don't use alternatives assessment other than in a very voluntary context. They use risk assessment. Quantitative risk assessment. And so do folks see this sort of as an evolution? With that, it's gone from risk to hazard, to inherent hazards, and now to alternatives. How do folks view this sort of what represents a paradigm shift? And how implementable do you believe that is in government contexts? If we have, for example, academics, scientists, and government folks in the room. And even businesses, we'd welcome to weigh in.
Hi there, Kathy. That was a good question. I'm Pete Derochet with the Dormitory Authority, and we certainly do try to use life cycle analysis hazard assessments for materials. We're looking for the green guard, certainly products, and we use a variety of other screening tools. I'm not in that particular area, the alternative, or rather the interior design, but that's one aspect of what we do. I'm in the actual abatement and remediation end of the business, but there too we try to use green remediation, trying to ship materials to the nearest possible disposal site, reuse as much as possible, which is hard to do in an institutional environment because of risk and liability and all that stuff. But so we certainly look at a lot of those things as much as we can to try to be sustainable, not only in the buildings, and going for LEED, but also in making it good livable environments and choosing sustainable alternatives. We have a task force for that purpose.
One thing where hazard assessment comes into good play, especially on alternatives, is it's a way of knocking out unacceptable alternatives, right? So you can use hazard as a screening tool for deselecting certain chemicals in your process to then get to having a greener alternative. So I think in that sphere where you're looking at, you've got a set of alternatives and you want to say, okay, which ones are more preferred? Hazard assessment plugs in, you can use it for deselection. And it, Kathy, then does fit into risk assessment as you want further information, right? And then you go, okay, well now we're going to go and do the exposure assessment to get to the risk assessment. Risk is hazard times exposure. So it fits in really nicely, and it's a way of not having to analyze so many alternatives, right? Because you can say, okay, well these are clearly not preferred. Now we've got these other ones, and now if you have three alternatives, you can say, well, okay, given the situation and likely exposure, likely life cycle impacts, which would I select?
I think that's one of the challenges of risk assessments, is knowing each use of a chemical and where the exposure might lie.
I'm Pamela Eisen with the Massachusetts Toxic Use Reduction Institute. So I'm sorry I missed the majority of this, but it's a great question that you asked. And I think, like Mark said, it's really important to be able to kind of narrow your scope quickly using hazard analyses. In Massachusetts, we are currently using alternatives assessment to try to identify potential alternatives that might be really regrettable. And case in point, we've just recently designated perchloroethylene as a high hazard chemical, which means that in Massachusetts, companies that use more than 1,000 pounds a year have to report on it. And many of these companies decided to switch over to NPB, which is also really, not the kind of chemical we want our companies using. So we're now starting to use alternatives assessment to not just analyze whether or not a chemical is of concern, but are there alternatives that may also be a concern, and then creating policy around that.
It would seem to save governments money to do that initial hazard screen and knock them out and not have to do risk assessments for each and every, and companies.
Well,
Money.
The tendency has been, and that's why I put that chaos, the slide of chaos of lists up there, right? The tendency is you go, and Pam puts a good example of that is, oh, PERC's bad. Well, let me go to the non-PERC solution or the non-regulated solution. So you go to look at that, and that's where, like, if you have a very narrow lens, you're going to miss out on the potential concerns of the alternative. And I also think this reflects our sophistication in thinking. We're now going, okay, yes, this is problematic, but we really want to avoid the regrettable substitution. We want to go to something that is safer, and it's a real challenge to create the tools and metrics to clearly show that you're doing that. But I think we've got a number of them that are available now to do that.
Hi, and I think you're absolutely right. The tendency to use the list, we're still doing that in New York. Big debate here about those kinds of things. But I'm wondering if you could speak more to the basis for all this, which is the amount of information we have. And the lists are based on a certain amount of information, and sort of dig into what the green screen is doing differently that the lists don't do. Like, how does it capture more? Because in the end, we have this basic amount of information about what chemicals do that's already limited. So I just want to understand better how green screen goes beyond the list and how they use that.
Well, so I'll take an oblique angle to answer your question, because this is the issue of data on the chemicals, and the real challenge is we lack comprehensive data sets on the chemicals on the market. Certainly, well, one way of getting at this, I'll go directly at it, is through legislation, right? So the European legislation, REACH, potential TSCA reform, Toxic Substances Control Act reform, would press that and start to fill those data gaps. So that's a real systematic solution to a problem. But in the meantime, what we're seeing happen in the electronics sector with the electronics companies like Hewlett-Packard are jumping over, right? Just think Hewlett-Packard, laptop over there, huge supply chain going into it. But over here are the chemical manufacturers, and you might have a half a dozen to 10 chemical companies that are providing data, providing chemicals into that supply chain. What Hewlett-Packard has done is they've leapfrogged over their whole supply chain to go to their chemical suppliers of flame retardants, for example, and said, okay, we want you to provide the data to populate green screen assessments, and we want you to provide that to an independent toxicologist so we can evaluate that information and get a better handle on its validity. So the key, and that's the key, is the chemical manufacturers have to provide the data, and then the question is, well, how are we going to get them to provide that information? So it's really a system solution, right? And so the green screen is this part that's sort of the back end of having that information. So So we really need to come up with system solutions, legislation, and what the marketplace is starting to do is a way of filling those data gaps.
It's interesting how Hewlett-Packard can demand that kind of information. Could you imagine if I called a chemical company and said, hey, I want to know what's in my infant teether? I don't think it would have the same, punch. Right? They can demand because otherwise we'll go elsewhere.
But
Anybody
you're pretty demanding, though.
I am. Anybody new? Anybody who hasn't spoken?
How are you getting the, I had a question for Barry. How are you getting the information about the chemicals? Are you getting the information on chemicals and products and their hazards from your suppliers?
The best source of information for us is we test. We test with GreenGuard. It's pretty serious, heavy duty, lots and lots and lots of money. We spend, I don't know, we may have spent close to $50,000 in the last year or two. That gives you some idea. For a fairly modest company, we're not tiny, we're not huge. That's how we get our information. We get other information too, but that GreenGuard tells us what we really need to know.
I have a question about use of resources. Mostly we deal with building materials and their toxicity and what's in them. A lot of times it's the built environment, so we have to deal with what's there already. Example would be, it used to be asbestos was the biggest problem. Now we found out we have PCBs in the caulks in various schools, dorms, and everywhere else. They made the caulk very pliable. It lasts a long time, but was it the best thing to do? But where do we spend our resources best? We could spend millions removing caulk, which right now EPA is studying it and saying how much of this is contributing to hazardous materials in the classroom environment. What if it's a part per trillion? What if it's 5 parts per trillion? Just comments for any of you to discuss. Well, how do we dedicate our resources to resolving these toxics that are incidental to our built environment, but they're there?
Well, I'll jump in. One thing that I think is really important, I mentioned BizNGO, we just had our annual meeting last week. One of the big topics is knowing the chemicals in the product. So we had a panel, we had Perkins and Will, we had Construction Specialties, manufacturer of specialty construction products, Healthy Building Network on the panel, and I think this is a critical foundation piece. Just like we have to know the hazards of the chemicals, we need to know what are the chemicals in the products. And so it's just a fascinating set of work going on. The Healthy Building Network has created this health declaration form. And they're working with specifiers, the architects, to say, okay, we're going to ask for you, building supplier companies, to provide this information. Because this is it's in every contract, even if you just ask, do you know the chemicals in your products, right? Every contract that New York State, put through it, and it's a checkbox, yes or no, but it sends a signal to the marketplace. You need to know, because the next step is, well, now that you know all the chemicals in the products, have you assessed them for their hazards? Have you ranked them? Have you prioritized them? I think if you could do one thing and ask in every contract that the state does, do you know the chemicals in your products? That's a huge signal to the market that you have to collect this information.
I have a couple of sort of concepts. I'm sure that it's widely recognized that it's beneficial to companies to have some sort of green or sustainable platform or product line or whatever. So it seems like there's a much more of a potential for greenwashing in that context. And I'm wondering how hazard and alternatives assessments, how you deal with that. How do we deal with that? How do individuals, like you mentioned, a very reputable and stringent certification, Barry, the GreenGuard. And, there's Pharos, there's Green Screen. But a lot of them are not so great, but they look real good to the average consumer. So, I know that that's a consideration, and some of them are downright fraudulent, but, many of them are just walking that wire, so.
There's a organic mattress being sold that claims to follow the standards of Naomi, NAOM, and Naomi, NAOMI, National Association of Organic Mattress Industry. Okay? Guess what? There ain't no such thing. So, greenwashing? Yeah. There are many examples of greenwashing. It's all over the place.
I'd say, systematically, I mean, I think, Kathy, organizations like yours, right, when you call out, if you call out companies for greenwashing, I mean, that has a huge impact. I mean, I think, this is one of the questions for the green screen. We haven't set it up as a third-party certified system, right? But, Barry mentions Green Guard, right? And there's many examples of that, of going down that pathway of saying, okay, let's create that type of system. But at the same time, you have companies going, oh, yet another label, right? Yet another eco label. So it's a challenge, but I think, ultimately you have to get to a system where you have transparency of information, what's there, and you have to have third-party verification. Transparency and third-party verification. That's the way to get around the whole greenwashing issue.
I assume that's somewhat a solution to the confidential business information. I'm sure many people are familiar with trade secrets, and if I have my secret McDonald's sauce that took me millions of dollars to figure out, I don't want anybody else to know what it is, because then they'll make money off of my. A lot of times it's used to just hide behind to keep toxic formulations a secret. So has that, do you just ding them if they're like, failure to disclose is enough of a whoa? Or, what do folks think about that?
It's hardball with Kathy. These are the real challenging questions. What we've been doing, so I mentioned before, BizNGO created these principles for safer chemicals. What we're doing is, so one of the principles is disclose chemical information. And what we're doing is creating a set of benchmarks to full disclosure. So the gold standard is full public disclosure on your label. But there's all kinds of incremental steps to that, right? You can disclose all the information to a third party who then does some type of assessment, and you'd have to trust that third party. That's the arrangement, right, that the Works has with Walmart. You could disclose the vast majority of it, like the cleaning product sector does. They say, okay, we'll disclose everything. This is Clorox is very interesting. They disclose everything except their fragrances, because the fragrance industry is just goes wild around their confidential business information. And then Clorox says, okay, we won't give you the individual fragrances for each product. Go to our website. Here's the 1,000 fragrances that we put in all our products. You can go and ding us for that, or you can get dinged, like you said, for non-disclosure. So like that's what Pharos and Healthy Building Network are doing, is you get dinged for non-disclosure. But I just think it's really important to lay out all these different levels of activity, because then you could go and you can assess companies, right? You could say, okay, well, where are you on this pathway? You're down here, you're not doing anything, you've done third party, or you've done full disclosure. So we've got lots of good examples in the business community of all of those.
Just real quick.
They won't catch you.
Just from the other side, the business side, other than HP and some of these companies that are participating, what kind of challenges are you hearing from the companies to say, with the boundaries of the green screen or other tools that are being used to assess these types of chemicals? What are some of the challenges or concerns that they have from their side?
Well, so we've been through a lot of them. I mean, there's the data, getting the data. I mean, I think it's interesting that Barry's spent $50,000 on Green Guard, because right now what it's costing companies, I think roughly, to run a chemical through Tox Services, who does some of these green screen assessments, is like $2,000 per chemical. So I mean, kudos to Barry. I mean, that's a significant investment that his firm has done. But so it's the information, and also then there's the alternatives, identifying the alternatives, and then Kathy put it out there. What are the what's the chemicals in the alternative, right? So then you have to do this sleuthing, you have to really pester your company, your suppliers to give that information. Typically you have to sign non-disclosure agreements. So it's getting the information on the chemicals in the products is your first challenge, and then once you have it is, okay, now how do I assess it? How do I get data on this chemical, even if now I know it? The chemical manufacturer is not providing information. How do you get that? So there's a number of different challenges, and I think it's a good question, because what we need to start to do better of is to show here are the different ways that the companies are getting at that information. And I think the Safer Alternatives, it's the Alternatives Assessment Wiki, right? Is that what are you calling it?
Safer Alternatives Wiki.
Safer Alternatives Wiki, the Interstate Chemicals Clearinghouse. That's like an example of where we can start to provide this information. I just think many of us that are really active in this area can really lay out these benchmarks, lay out how companies are going and filling in the information, because these are really good questions, really hard questions, and really challenging to answer.
Does anybody have any further questions for the...
I'll throw in a comment, just to make the point as to how difficult it is to get information sometimes. With mattresses in particular, most of the manufacturers won't even tell you what flame retardants are in the mattress, but that's only the first level. The fact of the matter is that some of the flame retardant manufacturers will not tell the mattress people what they're giving them. I posed as I am a legitimate mattress manufacturer. I posed as a legitimate customer. I told people I'd like to start buying your fire barrier, your flame retardant, and as if I really was. Please tell me what's in it. Nope. Can't get it. They just won't tell you. It's like you can't get that information out of some of these people, no matter how legitimate you might be,
They have these names for them, like Firemaster 550.
They won't tell you. They won't tell. And sometimes I'll tell you a couple things, but then like in one case, I finally got the whole list of what's in there, and I go, wow. But it took forever to get that list. And then, then even the easy stuff like the inherent fibers, the inherent flame retardant fibers. So half the time it's monacrylic, which is made from polyacrylonitrile, which is made from acrylonitrile, which is a carcinogen, and more than that. But they don't tell you that. You have no clue. And the EPA even says, oh, the inherent stuff is pretty good. Well, not really.
Any other questions from the audience? Okay, comment, great.
Back to you. Pete, nice to meet you. I work for DC. I work on the green procurement side and chemicals policy. But you asked a question about resources and priorities. And I think your example, I actually worked on the caulk issue when I worked for the Assembly. Very interesting. And I worked on brownfields and Superfund cleanup. And to me, the clear priority is prevention. Because if we, and to do what we're talking about today, because the caulk is a great example, they didn't know, so they used it all over the place, and now we're still finding it. So to me, I think the priority is the prevention side. So we know we have to prevent this stuff too. We don't invest in prevention. In New York State, this is my favorite statistic, we spend about $6 million, maybe $10 million a year on prevention, on kinds of funding for the P2I and other things. And he is gone, but that's Kate's here. So we spend, $1.5 million on the Pollution Prevention Institute. We spend over $300 million a year cleaning up hazardous waste sites and regulating end-of-the-pipe pollution. And taking care and controlling it. So we need to do more in prevention. And then with this, I think it's interesting. How do you decide which chemicals to tackle first? And in a way, you almost want to do a little bit of the exposure stuff to begin with. And I think we really have to give kudos to the Obama administration and what they're doing with the chemical action plans under TSCA. They finally started doing something about emerging chemicals and saying these are the ones we should look at. So we can start looking at those and saying, okay, let's try to move away from those. So there's some great examples out there. I don't think we have any lack of thinking about what the priorities are. I don't think we're really, doing too much that's not a priority.
Sure, brief.
I think Mark mentioned something about following up to public policy, and it's so crucial because in Region 2, we happen to have Judith Enck, who's being very cooperative about this issue and not going crazy about it. Yes, wanting the caulks out and other PCB sources, but in Region 1, they were literally tearing all masonry, which had residual caulk on it at the cost of millions of dollars to no good end. Not addressing anything, but there's an example of policy gone wrong. So I think that here, DEC, Region 2 Administrator, Inc. really have helped us in that regard. It's really important.
Okay, folks, we're going to close on that note, leave everybody wanting more, and I want to thank the panelists for their perspective on business, academia, government, and NGOs about how to assess alternatives and avoid regrettable substitutions. Thank you, everyone, for joining us.